dilemma
Mhm.
of, if everyone fends for themselves, we're all going to live in a horrible place. But if we're a little more altruistic, then we're all going to be in a better place. And I think it's not like we treat our kids differently, but they're just born differently. So in a way, as a geneticist, I have to admit that there's only so much I can do with nurture. That nature definitely plays a big component.
The selection of variants we have, the common variants and the rare variants. What can we say about the landscape of possibility they create? If you could just linger on that. So the selection of rare variants is defined how? How do we get the ones that we get? Is it just laden in that giant evolutionary baggage?
So I'm going to talk about regression. Why do we call it regression?
Mm-hmm.
And the concept of regression to the mean. The fact that when fighter pilots in a dogfight did amazingly well, they would give them rewards. And then the next time they're in a dogfight, they would do worse.
Mm-hmm.
So then, the Navy basically realized that, wow, or at least interpreted that as, wow, we're ruining them by praising them. And then they're going to perform worse. The statistical interpretation of that is regression to the mean. The fact that you're an extraordinary pilot. You've been trained in an extraordinary fashion. That pushes your mean further and further to extraordinary achievement. And then in some dogfights, you'll just do extraordinarily well. The probability that the next one will be just as good is almost nil, because this is the peak of your performance. And just by statistical odds, the next one will be another sample from the same underlying distribution, which is going to be a little closer to the mean. So regression analysis takes its name from this type of realization in the statistical world. Now, if you now take humans, you basically have people who have achieved extraordinary achievements. Einstein, for example. You would call him, for example, the epitome of human intellect.
Mm-hmm.
Does that mean that all of his children and grandchildren will be extraordinary geniuses? It probably means that they're sampled from the same underlying distribution, but he was probably a rare combination of extremes in addition to these common variants. So you can basically interpret your kid's variation, for example, as, well, of course, they're going to be some kind of sampled from the average of the parents with some kind of deviation according to the specific combination of rare variants that they have inherited. So, given all that, the possibilities are endless as to sort of where you should be, but you should always interpret that with, well, it's probably an alignment of nature and nurture. And the nature has both the common variants that are acting kind of like the law of large numbers and the rare variants that are acting more in a Mendelian fashion. And then you layer in the nurture, which again, in everyday action we make, we shape our future environment. But the genetics we inherit are shaping the future environment of not only us, but also our children. So there's this weird nature-nurture interplay and self-reinforcement where you're kind of shaping your own environment, but you're also shaping the environment of your kids. And your kids are going to be born in the context of your environment that you've shaped, but also with a bag of genetic variants that they have inherited. And there's just so much complexity associated with that. When we start blaming something on nature, it might just be nurture. It might just be that, well, yes, they inherited the genes from the parents, but they also, were shaped by the same environment. So it's very, very hard to untangle the two. And you should always realize